So to simplify a radical, we need to break up the number into smaller pieces so we can see which pieces are going to stay inside and which pieces can come outside as perfect squares or perfect cubes. So to do that, our first step is we draw a factor tree. Then we group by the index. Now, one thing that we do have to keep in mind is the square root. Because it is such a common radical, we actually drop what the index is. And the index, remember, is the number that is in front of the radical. So for example, like this cube root of 120, that would have an index of 3. So the index here is equal to 3. But with the square root, you don't see an index. And the reason why you don't see an index is because it is understood, if we're talking about a square, that the index is 2. So that's the real issue, is that when you see a square root, you need to just remember that the index is 2. It's understood to be 2. Square, you kind of think about 2. If you're squaring a number, you're raising it to the second power. So our index is equal to 2. Otherwise, the index will always be shown. So here, like cube root of 120, we see the index of 3. Now, we group by that index, and then the grouped numbers, we will have one copy outside of the radical, and the ungrouped numbers will stay inside of the radical as is. So let's look at a couple of examples of this process of factoring, grouping by the index, and then the grouped numbers are going to go outside, the ungrouped numbers will go inside. All right, so we're going to start with cube root of 81 versus the square root of 81. So for both of these questions, my first step is I'm going to need to draw a factor tree for 81. So if you don't know what 81 is divisible by, it is an odd number, so it might be a good guess to divide by another odd number. So for example, you could divide by 3. So you would take your calculator out, take 81 divided by 3, and that gives you 27. Now, we have to factor further 27. 27 is also an odd number, so we can divide that by 3. When we take 27 divided by 3, we get 9. And then 9, as an odd number, can be divisible by 3. Now, this factor tree as it's written kind of is confusing because you have a 3 over here, you have a 3 here, and so on. So what I want to do is I want to bring down all of these numbers so I have a stable 3 with all of the last line of the factor tree written out. All right, so once I get my factor tree, then I group by the index. So for this first example of the cube root of 81, the index there is equal to 3. So because the index is equal to 3, I am going to group in 3s. So I have one group of 3 3s, and then I have a leftover 3. So what that means is that inside of the radical, I am going to have 1 3 left over. So I write that inside of the radical. Now the radical had a cube root index, so that's going to have to stay as a cube root index. Now, outside of the radical, this circled pairing, this grouped number, that is going to appear outside as one copy. So we will have outside of the radical one copy of 3. So our final answer is going to be that the cube root of 81 is 3 cube root of 3. All right, now let's contrast that to if it was the square root of 81. So if it was the square root of 81, I would still have the same factor tree. I would have 3, 3, 3, 3 as my factor tree. But now, because the index of a square root is understood to be 2, so square, if I square something, it's understood that I'm raising it to the second power, so the square root has an index of 2. So now I am going to group in groups of 2. So if I group in groups of 2, I have 2 3s here. So that means I'm going to have one copy of 3 outside of the radical. And then I have another group of 3s in groups of 2. So I'm going to have another copy of 3 outside of the radical. So these circled numbers, I always think about the circle means that you have a copy of it. So I have one copy from here, and then I circle these. So that means I have one copy from here. So then I just take 3 times 3, and I get that my square root is equal to 9. Now, let's